on text processing in NLP. So before we begin with the session and before we deep dive into our topic, just allow me to introduce our today's speaker, and let me give you a short introduction about her. So today we have Professor Nida Parkar with us, and to give you a short introduction about her, she is a professor at Aegis School of Data Science, and she has an experience of overall more than 11 years in the same industry. And the specialization subjects that she teaches are Python, machine learning, deep learning, natural language processing. So today, let's just get to know about how you can process text in natural language processing. So over to you, ma'am.
Thank you, Suyog, for your brief introduction. A warm welcome to all the participants over here in this meet. Welcome to this meetup. Let me quickly share the screen and then I can start with the topic. So the topic for today's meetup is text processing in NLP. NLP is nothing but natural language processing. Okay. So before we deep dive into how do we do text processing in natural language processing, let's first understand what is natural language processing and where in our day-to-day lives do we use this natural language processing. I hope my screen is visible to all of you. IT team, can you please confirm if the screen
is visible? The screen is visible. We can see it.
Okay, thank you. So what is NLP? So to just, put it in one sentence, NLP is nothing but insight from the textual data. Okay, so when I'm talking about today, we are living around the buzzwords AI, data science, ML, deep learning, machine learning, and natural language processing. So today I'll be taking a part of this data science analysis that is dealing or using the natural language processing. So in short, if I have to tell in one line to any layman person, what is natural language processing? Is basically understanding some insight from the textual data. Now, to the Wikipedia meaning of it is natural language processing refers to the branch of computer science, more specifically the branch, or you can classify it to be a branch of artificial intelligence concerned with giving computers the ability to understand the text and spoken words. Okay. Now, there are two words in this natural language processing that we see, that is natural language. Now, suppose if I ask you, what are the natural language that we know in our day-to-day life? So we speak English, that is a natural language. We speak Hindi or French or any other language. These languages, you can call them as a natural language. So get the meaning out of this natural language, or the way in which human speaks or write some information, to get some insight from this kind of data, we deal with an area which is called as natural language processing. To understand this diagrammatically, if we have the whole thing into AI, so AI has a lot of things like robotics, data science, and dealing with a lot of things. Machine learning is a part of AI and deep learning is a part of ML. So natural language processing uses both machine learning and deep learning algorithms. But before you give the data to the machine learning and deep learning models, you need to pre-process the data, because the data is present in the form of textual data. Suppose you are giving some review to a movie. So that is the way in which humans speak or write. The movie was good, the actor was not that great. So you would write up these words. How would any machine understand what exactly are you trying to interpret by writing in those sentences? So that area is nothing but your natural language processing. Let's proceed further. Some of the applications of natural language processing is Alexa. When you ask the Alexa, what's the temperature today? So, you've given the input as the sound, as you speak, or your speech data, it converts it to textual data. Some processing takes place, that is, it gets converted to words. The data is interpreted back then, and then you get the output in Alexa's voice, as into whatever question you have asked to Alexa, it would give you the output in that regard. Okay. Another way, why do we use natural language processing? Where do we use natural language processing? You must have come across this. Any idea what this is? This is nothing but the Google Translator. You can just go on to Google, type Google Translator. It allows you to translate one language to the other language. So suppose you are typing in hello in English language and you want the output, what is hello called as in the French language. So it's called bonjour. So it gives you the uh, transformation of one language to another, that is using the natural language processing. To understand it better, how the Google Translator works, you give in some input to the data. There is some algorithm that it works on. You build a model, and then it takes there is a model which is being trained on some input data. So it doesn't know just by you giving the input wherein hello is bonjour in French. So wherein the model has already learned few words or languages, and then you give in the input using whatever word you want to convert, and then accordingly you will get the output in the other language. So let's understand what are the different applications of natural language processing. So a few applications which are already you are using in your day-to-day life, which you're not aware of. One of the application is text classification. Today I'll be showing you a hands-on for this text classification, as in how we give the data, what kind of data it works on with natural language processing, how actually it classifies the text. So suppose you have your email giants like Google, they already do it for you. You have some tabs in your email which deals with inbox messages, and there are spam messages. How does Google understand which is an important message and which is a spam message? So there it performs the text classification using natural language processing, due to which it is able to understand which is an important email and which is not. Another example is sentiment analysis. So let me talk about the sentiment analysis. Suppose, as I was talking about movie reviews, suppose there are lots and lots of people who have given the movie reviews about some movie, and you want to understand, I hire up a person and tell, go through these 1 lakh reviews that are there with you, and please tell me whether more people are giving positive, negative, or neutral reviews. It will be a very time consuming process for any individual to go through these 1 lakh records and give the output whether it is a positive, negative, or a neutral review. So here we can use the natural language processing to understand what is the sentiment present in the particular text or the review, and accordingly you can get the output whether it's a positive, negative, or a neutral review. Text summarization. Some of the news apps use that for you. So they give you a summarized information. Suppose there's an article which is very large and you do not have time to read up that article. So they actually summarize the article or the news for you and give you only the summarized article. So you get the gist of the news and you're updated with whatever the current news are. Many of the websites are using chatbots because suppose a person visits any website which is about some product, and in which you want some basic information about the product. So many of the websites have inculcated this chatbot into their website. So as they are not keeping a human engaged continuously, wherein a query is raised on any of the questions. Suppose you want to ask the basic questions like what are the different range of products, or what are the different price of products. So all these are handled nowadays using the chatbot. Next, word prediction. You may have already come across this. Whenever you type something in Google, so there is something like you type in the words, and suppose I want to search something like where is this, where do I get the food in, it gives you a lot of options. So that is nothing but Google is already predicting what is the next word for you based on whatever sentence or half sentence that you've already typed. Another application of your natural language processing is nothing but fake news detection. So based on whatever is the content of the news, you can analyze it using your natural language processing, and you can actually classify whether it is a fake or a actual news. So these are a few of the applications of natural language processing. Some of them we do use in our day-to-day life. Some of them we are aware of. Some of the applications which we are not aware of. So let's proceed further understanding more about natural. So not that any natural language processing, like any other, also has few of the challenges. So not every text or not every kind of text can be analyzed. So suppose, there is a word sense ambiguity. That means if you tell, please have a seat, okay? That means you are telling the person, please take down the seat or you can sit down on the chair. It doesn't mean that you can have the seat and take it along with you. So yes, there are some words sense ambiguity that NLP is not able to determine. But with a lot of new language models coming in, which are trained on very high parameters, they are able to handle this as well to some extent. Then you can say that if there is any sarcasm, I was talking about the movie review. So suppose it says that, the movie was, the good part about the movie was nothing. So there is an important word like good, which may tend to tell the NLP that the movie was good. But when you hear the overall sentence that the good part about the movie was nothing, it actually means that the movie was not a good movie and it should be classified as a negative sentiment and not a positive one. Mixing, code mixing, two languages used simultaneously. As it deals with natural language processing, so it has the capability to handle only one language at a time. Suppose there are a lot of reviews which deals with mixed languages, like one language, so half of the sentence is in one language and another one is in some other language. So yes, it will be difficult for NLP to handle this kind of data. Again, language is not static overall. There is overall, you can say the languages follow the grammar, but sometimes, not all the times the language is static. So that's why these could be a few of the challenges that a person could get while doing or working with your natural language processing. Let's understand what is the pipeline when you're working on any data that uses the natural language processing. So basically, you take up any textual data. Okay, now understand that the machine learning algorithms work on numerical data. When it comes to textual data, they are not able to process the textual data. Through the natural language processing, you need to convert those textual data to some numerical form, or what we call them as vectors, which further you can give it to the machine learning algorithms. So there's a pre-processing that needs to be done before giving any textual data to any machine learning model. Now, based on the problem statement that you're dealing with, you can either pre-process the data and give it further to a machine learning model, or you can also give it to the deep learning model. All right. So moving forward, what is the pipeline of your natural language processing? You put in the text document, then you tokenize the sentences are taken up. You tokenize, we'll see each of these things in the coming up slides. What is tokenization? What is parts of speech tagging? What is lemmatization? What is stop words and why should they be removed? What's dependency, noun phrases, name entity recognition? So all of these things we'll take a look at one by one. And why are these things important when you're dealing with the textual data? Now understand that there is a lot of grammar involved when you're dealing with any textual data. You need to understand what the sentence is, what is the grammar, which is the noun in the sentence, which is the entity in the sentence. So a lot of these things are required to be processed whenever you're taking or working up on any textual data. So let's understand a few important steps like lemmatization, stemming, tokenization, parts of speech tagging, stop word removal, named entity recognition. So let me proceed further by taking up the first step that is called as tokenization. A simple example that I would like to give about tokenization is, suppose you have a sentence, it is a great day. If you are breaking down into tokens, now there are so basically when we are doing the natural language processing, there are two very famous libraries that we talk about. One is the NLTK, that is the Natural Language Toolkit, and the second is your Spacey library. So these are the libraries that work very well or widely used with any textual data that you are processing upon. So using these libraries, okay, both libraries can be used. They have their own functions. The good part about these libraries is they have their own built-in functions in which you pass the sentence and it will directly give you the output in this form. So suppose you have a data like it is a great day. So it is going to break down each word. So here the separator acts as a space that you have over here. So it is a great day. Each word that you have in the sentence is considered as a token. All right. Once this is done, we have something called as stemming. So stemming is, you can say that it is a heuristic process that chops off the end of the word and converting the word to the stem, and that's the reason it is called as stemming. There are some examples that are given over here: consign, adjustable, studying, formality. So when you take up these words and when you perform the stemming of these words, it is going to give like consign, adjust, study, and formality. If you see this, the formality word is getting transferred to formality with a I. Now, English dictionary does not recognize this word. So over stemming, there is another process which is called as lemmatization. So again, lemmatization is a process to convert to the base word. But given the previous example, if you give this word formality to the stemmer, there are a lot of stemmers like Porter stemmer and other stemmers that are being used to convert this word to the stem word. So it will keep formality as it is in formality and not change it to anything else. Another example that you can see over here, suppose there are different words like help, helping, helped, helped. So these words are converted to the base word that is help. Okay. So if you take a look at these words, all these words have their base word to be help. So that is what your lemmatization is all about. When you're talking about parts of speech tagging, we've seen parts of speech tagging when we were in school, grammar. So it basically gives the tags given to the tokens or the parts of speech. Parts of POS tagging is nothing but parts of speech tagging, wherein it recognizes what is a verb, what is a noun, what is a pronoun. So if I give this sentence, I am a runner running in race because I like to run since I ran today. So these are the words that I give to this parts of speech tagging. So you can see that it tags like I to pronoun, am to auxiliary, then D is determinant, then runner. Since the base word here is run, so it is categorizing it as noun. Likewise, it is giving for run, it is giving runner, it is categorizing it as noun, and ran, it is categorizing it to be verb. So each and every word is given the parts of speech. Now, why are all these steps important? That I'll talk in a while once we complete the different steps. Second is the named entity recognition. If I'm giving a sentence like Apple is planning to open a new factory in India for $8 billion. So using the named entity recognition, it is going to identify Apple as an organization and not Apple is also a fruit. But the named entity recognition is trained so well on so many modules and words that it is able to recognize Apple is as an organization. ORG means it stands for companies, agencies, institutes. Also, in this particular sentence, it is able to recognize India as a GP, that it means it is one of the countries. Anything that comes under countries, cities, or states falls under the category of GPE. And 8 billion, the interesting thing to see over here, when we are talking about $8 billion, it is telling that $8 billion is about money. And the description that you get over here, that it is a monetary value that is including a unit. Since there is a dollar given over here, so it is telling that there is also a unit mentioned to it. So why do we need to work on these things or identify these things? So let me give you a simple example. When you're talking about the movie was good movie, so which of the word in the entire text are you going to give emphasis to identify that the review was a good review? So there are words like good, was a good movie. So, apart from this word good, there is no other word in this sentence which enables you to tell that the review is a positive review, right? So that's why we need to identify what are the different words, which word should be given more weightage. So we are not bothered of the words in the particular sentence. The movie was the words like the, okay. So these words are nothing but stop words. Words like and the appear so frequently that they do not require tagging as thoroughly as nouns, verbs, or any other modifiers. We call these words as stop words and they can be filtered from the text. So what we do is we remove these stop words using some pre-processing techniques like you can use regular expression and as well as these libraries, that is NLTK and Spacey, have got built-in functions which allow us to remove these stop words. So, for example, Spacey holds a built-in list of around 305 English stop words. Probably now it may have increased. That also depends on which language model you're using. So, for Spacey, we can deal with a language model which is a small or medium or large. So depending on which model you are using, it tells you how many stop words do you have in that. So to take a brief at whatever I was talking about right now, to sum it up, suppose you have a input tweet like, it was a great match played yesterday. Thanks to all my friends. So this is the input tweet we have. And you want to identify whether this tweet was a positive or a negative. So how are you going to proceed? You know, that part comes later wherein you can identify the overall tweet to be positive or negative. But first you need to do the pre-processing. So what the first step that we had seen, initial step, was tokenization and text cleaning. So as I said, when you're doing tokenization, each of these words is broken down into different tokens. So your great match played yesterday, thanks friends, is a token. But you also see that few of the words that are written over here are missing over here. That's because of the other thing that is being written over here, that is text cleaning. Okay. So now let's see what are the things that are being performed under the text cleaning. There is a remove emoticon. So you have removed this emoticon because again, it is not a textual data. It is difficult to handle it at later stage. So you have removed it. Then you can see a abbreviation, that is thanks. The English word for thanks is thanks. Okay. So that word is being replaced to its proper word. Then there are some punctuations that you can see over here. You have removed those punctuations. If not removed, even the punctuation that you have, even the emoticon that you have, will be considered as a token over there. So this emoticon will be a token. This comma will again be a token. Okay, so each and everything that you see over here will be considered as a token. So here you can see that you have removed the stop words like to, all. So these are all the stop words. It. So all these words have been, and also you have removed the smaller words. It was mine. So after you have done text cleaning and you have performed tokenization using either of the libraries, that is Spacey or NLTK, this is what you get. Now the words that you have over here, looking at these words, you will be able to identify whether you can identify the sentiment from this, whether it was a good match or not. All right. So let's move further. When we've already spoken about POS tagging. So in the POS tagging, it will tell you whether what is this, great is an adjective, match is a noun, played is a verb, yesterday is again a noun, thanks is a noun, friends is a noun. So it is giving you what each of these words stands for in whenever you want to know for the parts of the speech. So you've seen two techniques. Now these words also have to be reduced to their base words. So we have seen two techniques, that is stemming and lemmatization. Using stemming and lemmatization, you can reduce them to the base word. Like you can see great, the base word for great is remain to be great. Match is remain as it is because you cannot reduce it further to the base word. If you see over here, played, the word played has been reduced to its base word, that is play. And the even the thanks that you see over here. So stemming lemmatization, remove the ending S generally. There are certain rules that take place while doing the stemming and lemmatization. Even for friends, the S has been removed, and these are the base words that you are able to see. I would like to move to the example which I wanted to show of text classification. So allow me to share my screen. I hope my screen is visible to all of you. So this is the code I have written. First of all, let's take a look at the data. So this is the data that is having some input messages that you see over here, some numerical columns and some textual columns that you have over here. And there are certain labels that are there, whether it's a spam image or whether it's not a spam image, that is classified as a ham image. So based on the sentence that you have over here, you would want to classify. Now, suppose you want to give this data to the machine learning model. The only data that you could give to the machine learning model is these two columns, because they are numerical columns and the machine learning algorithm work on numerical columns. Suppose you want to work now, if you want to, now generally, even when you're talking about the email, suppose you want to identify whether it's a spam email or not. Just by looking at the length or the punctuation, it would be a little difficult task for you to identify whether it's a spam or not. But when you actually take a look at the sentence that has been written there, you will definitely come to know whether it's a spam message or not. So one such example we are going to see over here, wherein we are having around 5,000 such messages. We are going to train our model to identify whether it is a spam message or not. Okay. So this is the code that I've written in Colab. I've already executed this code because considering it to be a NLP code, it takes some time to process and download the libraries. So the data set which I've already shown you is this data set. Now, while we are dealing or talking about the textual data, we are only going to look at the textual data. So I'm going to drop these two columns, and the only focus data is going to be this column, which is with the header message. So if I go further, the data that I'm considering is only the message data. Later on, what has been done is the data has been trained. There are certain techniques like bag of words and TF-IDF, which actually converts the data from your words to vectors. So one such example that I would like to explain is, suppose you're having a sentence. I ran today to school. Then the second sentence is, I ran yes. Okay, suppose I have these two sentences. Now if you can see, there was a repetition of the word ran. So bag of words is nothing but simply a representation of the words into the how many times the word is appearing in that particular sentence. That is nothing but the bag of words. And TF-IDF is basically, it also converts it to vector form, but it also takes up some logarithmic values, which is a better, some cases TF-IDF works better than bag of words. In some cases, you may apply only bag of words and not TF-IDF. TF-IDF is, it actually works on the entire document and not only on a specific sentence. So this mechanism is used over here. SVM is basically a model in your machine learning. It's used for classification model. Since the data that we are dealing with is of classification type, wherein we want to understand whether the message is a ham or a spam message. So let me go back to the final result. So this sentence was given to the model to predict whether it is a ham message or a spam message. So it is able to classify it to be a spam message. Let me try giving another sentence to it. So instead of this message, I will write something like, hi, please schedule a meeting for me at 10 a.m. tomorrow. So let's see whether the model is able to predict this to be a ham or a spam. Now, if you take a look at the previous message, hi, you won a lottery of some dollars, grab your free amount now. So because there's a word like free and the lottery amount and the word like lottery, based on these words which are already being processed, it is able to classify that it is a spam message. So when I executed this, you saw that the sentence which I've written, hi, please schedule a meeting for me at 10 a.m. tomorrow. It looks like a genuine statement. So that's the reason Since the model is already being trained, it is giving the output to be a ham message. That means the message that I have typed over here is not a spam message. So this is how we can use the natural language processing for any text classification wherein you would like to classify it to be a ham or a spam. So just to take you through, I've used a pipeline over here, wherein the first step is to convert it to vectors. IDF, it allows it to convert to vectors, that is some numerical value of your words that you have, because the HVC model, that is a classification model that we are using. It doesn't take any textual data. So prior to that data, we need to do some pre-processing by converting it to TF-IDF vector. And prior to this TF-IDF, we can also apply the pre-processing steps that I have spoken about, like removal of step words, coming down to the base words. And after that, maybe you can convert it to your TF-IDF vector. So the vector can be given as the input to this classification model. And based on that, this is any classification model deals with the accuracy, what is the confusion matrix. It tells you whether the model is a good model or not. So since the data was small data, these 1,447 of the sentences, it was able to classify it to be spam messages, and they were spam messages. And the 198 messages, it was able to classify to be ham messages, where those were the ham message, those are actually the ham messages. So based on the labels, you get your confusion matrix over here. Let me move back to the PPT. So that was an example which I showed you, which actually wherein you could give a sentence, and using the natural language processing, and along with that further using the machine learning model, you could actually understand whether the sentence that you had given, and if you see the sentence which I had written was the way I would talk to anybody when I would have to schedule a meeting. So it said that, please schedule a meeting for me tomorrow. So it was able to understand a human natural language and get the output, which was nothing in the form of a classification, whether it was a good or, a ham or a spam message. So moving further, there are a lot of pre-trained models which are already available in the market that are having, or trained on huge parameters. One of the examples is GPT-3. It is a pre-trained transformer, or GPT-3, which is capable of writing stories, scripts, poems, articles, as well as codes. So that's the power of GPT-3. Let me take few examples. So suppose you give the input, the sky is full of, and the output it would give you is the sky is full of clouds. Another GPT-3 example, suppose you are having a movie, Back to the Future or anything else. So it will actually convert it to the emojis. So this sentence, this is a screenshot which I've taken by trying out the API of GPT-3. So I've written movies like Back to the Future, Batman, Transformers, and it is giving you the emojis it is giving you. So Finding Nemo, so it is actually giving you a fish, and because there's a word like finding, so it is giving you a magnifying glass. And Jaws, because it has been pre-trained earlier, Jaws is related to shark, that's why it's giving you this output. So to sum it up, you can say that natural language processing deals with the area which actually deals with your textual data. Whenever you have to deal or work on any textual data, you need to apply natural language processing, and which further you can give it to any machine learning or deep learning model. Lastly, to understand what exactly is data science, I would like to show it in this screen. So data science is basically something that is deal with mathematics, domain expertise, and the knowledge of computer science. Okay. When you're talking about mathematics and computer science, that is where your machine learning stands. So machine learning models are highly based on the mathematics and statistics. And to understand or to code the machine learning language, you would require a programming language like Python or R. That is where machine learning stands. When you have the domain expertise and when you have the knowledge of mathematics, that is what you have an expertise as a statistical research. And whenever you have a domain expertise and you have some coding language that you're aware of, you can definitely process the data. So where all of these things meet, that is nothing but you can call this area to be data science. So in short, data science is nothing but getting some insight from the data or analyzing the data for using it so that you can use it for, suppose a marketing manager wants to know that, if the product has been launched and how well the product has done. So maybe by collecting the reviews of the people by some scraping mechanism, collecting the reviews that the people have given, the company can identify whether the product has got some good reviews or not. Okay, and that can be further processed further by giving it to the machine learning model to understand that whether the new product is to be launched in which coming months, or what is the change that you need to do in the coming up or the updated version of that product. So that was the whole idea about understanding the natural language processing and how it falls under the category of AI, and how can you use it for analysis of any textual data. So I would like to know if there are any questions related to this. I am ready to take up any questions if you have regarding the whatever I have presented or related to data science, machine learning, deep learning, or natural language processing. Participants, do we have any questions? You can also put in the question in the chat box if there are any questions. All right. So I guess there are no questions. So then I would like to take a leave with telling the code that today is the era wherein data science is being used in each and every domain. People who are working with traditional methods are also wanting to learn data science or some way to process the data. So, and natural language processing, since the meetup was about the natural language processing, so definitely natural language processing is very useful whenever you're dealing with any kind of textual data, and it is being used in various domains. So that's all from my end. Thank you for attending, and have a great day. Thank you.